Welcome to aminacademy.com. In astronomy, let us discuss about radiation and spectra, then the behavior of light. The visible light and other radiation we receive from the stars and planets is generated by process at the atomic level, by changes in the way the parts of an atom interact and move. Thus, to appreciate how light is generated, we must explore how atoms work. There is a bit of irony in the fact that in order to understand some of the largest structure in the universe, we must become acquainted with some of the smallest. Light waves across the electromagnetic spectrum behaves in similar ways. When a light wave encounters an object, they are either transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered, depending on the composition of the object and the wavelength of the light. Maxwell's described light as a propagating wave of electric and magnetic fields. More generally, he predicted the existence of electromagnetic radiation coupled electric and magnetic fields traveling as waves at a speed equal to the known speed of light. We will look at the structure of the atom in some detail later before that, but we begin by noting that the typical atom consists of several types of particles, a number of which have not only mass but an additional property called electric charge. In the nucleus, central part of the atom, of every atom are protons which are positively charged. Outside the nucleus are electrons which have a negative charge, and neutrons have no charges. Maxwell theory deals with these electric charges and their effects, especially when they are moving in the vicinity of an electric charge. Another charge feels a force of attraction or repulsion. Opposite charges attract, like charges repel. When charges are not in a motion, we observe only this electric attraction or repulsion. If charges are in motion, however, as they are inside every atom and in a wire carrying a current, then we measure another force called magnetism. Magnetism we will know for much of recorded human history. Here, a brief review of Maxwell's theory. Maxwell not only developed an entire electromagnetic theory represented by Maxwell's equation, but brought along all the work that has been done by good physicists like Ørsted, Coulomb, Gauss, and Michael Faraday, and added his own insights to develop the overcharging theory of electromagnetism. Overarching theory of electromagnetism, Maxwell's equations include most important laws of electricity and magnetism. Maxwell calculated the speed of an electromagnetic wave, and he found that the speed of an electromagnetic wave was almost identical to the speed of light. What Maxwell's electromagnetic wave theory? According to the Maxwell's AM electromagnetic wave theory, light waves are related to changing electric field and magnetic field. The charge within the electrical and magnetic field leads to the propagation of electromagnetic waves or light waves. The main points of this theory are: the energy is emitted from any source continuously in the form of radiation and is termed radiant energy. Next one, the radiation includes electrical and magnetic fields oscillating perpendicular to each other and both perpendicular to the direction of propagation of the radiation. Radiation process. Radiation possesses wave characteristics and travel with the speed of light. The radiations are known as electromagnetic radiation or electromagnetic waves. These waves don't need any material medium for propagation. The waves can read in empty space also. Electromagnetic wave. An electromagnetic wave consists of an electric field wave and a magnetic field wave oscillating back and forth, aligned at right angles to each other. The oscillation of the electric part of the wave generates the magnetic field, and also the oscillating of this part successively produces an electrical field again, on and on, because it travels through the space. Electromagnetic wave. Like any other wave, electromagnetic radiation includes a frequency and a wavelength, and the product of these is always equal to speed of the light, c. Electromagnetic waves are all around us, and as well as visible radiation. Other wavelengths are usually known as radio waves, microwaves, infrared, ultraviolet, X-ray and gamma rays. All of these types of electromagnetic radiation have a similar basic kind as explained by Maxwell's equation. However, their energies vary with frequency. That is, higher frequency means the higher energy. If frequency is more, the energy that waves contains is more. The equation of electromagnetic wave explains the transmission of electromagnetic wave in a vacuum or other wave medium. Now we'll discuss about light. Light as a photon. Before that, the wave-like characteristics of light we'll explain. The changing electric and magnetic field in light are similar to the waves that can be set up in the quiet pool of water. That means it's propagating. In both cases, the disturbance travels rapidly outward from the point of origin and can use its energy to disturb other things farther away. The waves generated by charged particles differ from water waves in some profound ways. However, water waves require water to travel in. The sound waves we hear, to give another example, are pressure disturbances that require air to travel throughout. But electromagnetic waves do not require water or air. The fields generate each other and so can move through a vacuum such as outer space. This was such a disturbing idea to 19th century scientists that they actually made up a substance to fill all the spaces, one for which was not a single shred of evidence. The other difference is that all electromagnetic waves move at the same speed in empty space, like a light speed, nearly about 3 into 10 power 8 meter per second. Now, a nice thing about a wave is that it is a repeating phenomenon, whether it is the up and down motion of a water wave or the changing electric and magnetic fields in a wave of light. The pattern of disturbance repeats in a cyclic way. Thus, any wave motion can be characterized by a series of crest and trough, moving from crest through a trough to the next crest to complete one cycle. The horizontal length covered by one cycle is called wavelength. Now we'll discuss about light as a photon. The light behaves mainly like a wave, but it can also be considered to consist of a tiny packages of energy called photons. Tiny packages of energy is called a photon. Photons carry a fixed amount of energy but have no mass. The energy of photon depends on its wavelength. Longer wavelength photons have less energy, and shorter wavelengths photons have more energy. Longer wavelength photons have less energy, and shorter wavelengths, photons have more energy. Photons are known as a light quantum is a minute energy packet of electromagnetic radiation. A tiny particle of packet of electromagnetic radiation is called photon. The idea of photon arose in 1905 from Albert Einstein's description of the photoelectric effect, in which he suggested the presence of discrete energy packets during the transmission of light. Propagation of light, how light propagates. The process by which an electromagnetic wave transfers energy from one point to another is referred to as a light propagation. When light passes between boundaries from one medium to another, three major processes occurs: transmission, reflection, and refractions. Now we'll discuss about some laws about electromagnetic radiation. Inverse square of light. Look at here, the light source is here. Here, near to light source, this is area covered is less, so intensity is more. If propagated outer and outer from the source, this intensity reduces. The light intensity decreases with the distance from source to receiving surface, that is a sink here, body sink, and the rate of decrease is in proportion to the square of the distance between emitter and receiver. That means the intensity inversely varies with the square of its distance from the light source. Next. The average speed is equal to distance by time. It's a basic formula for speed of any moving particles. Now, wavelength. Wavelength is lambda equals c over f. That is light speed of light over frequency. Now, further discussion about light as a photon. The fact that light behaves like a wave in certain experiments and like a particle in other experiment was a very surprising and unlike uniquely ideas. After all, our common sense says the waves and particles are opposite concept. On one hand, a wave is repeating disturbances that, by its very nature, is not in only one places but spreads out. A particle, on the other hand, is something that can be in only one place at any given time. Strange as it sounds, though countless experiments now confirm that electromagnetic radiation can sometimes behave like a wave and at other times like a particle. Then again, perhaps we should not be surprised that something that always travels at the speed limit of the universe and does not need a medium to travel through might not obey our everyday common sense ideas. The confusion that this wave-particle duality of light caused in physics was eventually resolved by the introduction of a more complicated theory of wave and particles, now called quantum mechanics. So far we discussed about little about what is photon, inverse square law of light, propagation of light, light as a photon, as well electromagnetic wave, some introduction, and Maxwell's electromagnetic wave theory, like some brief explanation we have done. Please subscribe our YouTube channel.